Let's take a few minutes and look at the scoring rubric for the second of the mock free response questions. So the first section of the rubric is based on part A of the question by itself. The second section of the rubric combines parts B, C, and D together. Then the third and final section of the rubric is about part E and only part E. So let's take a look at part A. In part A of the question, let me scroll down to it. Here it is. So in part A of the question, we are asked to find the approximate probability that a randomly selected aspen tree in this park in 1975 would have a diameter less than 5.5 inches. Okay, so again, I'm not showing you the correct answer. I'm showing you an example of an answer that you might have written, and then we're going to look at how to apply the rubric to this answer. So there are 5 components. Number 1, use of the normal distribution has to be explicit. In other words, I have to see a picture, I have to see the word, or you could use this notation right here, n, and then the mean, comma, the standard deviation. I have to be able to see use of the mean and the standard deviation. So that could be satisfied actually by filling in the mean and the standard deviation in this notation. Showing a z-score calculation would also accomplish that. I also need to see the direction of less than. So let's start with those first 3 components. So the first component is not satisfied here. I do not see normality anywhere in the way that this answer is described. I can see the use of the mean here and the use of the standard deviation because I wrote the work for the z-score. And I can also see the direction here. But somewhere in this work, we need to refer to normality. And frankly, I like this notation. We're using a normal distribution with a mean of 8 and a standard deviation of 2.5. So here, I've got my distribution. I am using this z-score. So I've now got my reference to normality. I have my use of the mean and the standard deviation, and I have the direction. So now the answer has to be described as a probability, or probability notation needs to be used. Nowhere in this answer am I describing that this is a probability. The easiest way to do this would be just to copy the words. Find the approximate probability. Well, fine. Say the probability that a randomly selected aspen tree in this park in 1975 would have a diameter less than 5.5 inches is blank. So literally, you can copy the words to get the word probability in there. In my opinion, there's probably a simpler way to do this, and it involves this expression right here. I see students write this expression, and this is really a very sloppy expression, which is mathematically incorrect. This expression actually states that -1 equals 0.1587. That's hardly a true statement, and that's not what you're trying to tell me here. It's just poor communication. What you really mean is the likelihood of a z-score that's less than -1 in a normal distribution is this probability, or the area under the normal distribution with a z-score that is accounted for by z-scores of -1 or less is about 16%. So you can clean this up by using probability notation, which is strongly what I would advise you to do. Now this is a correct statement. So before it was mathematically a completely incorrect statement. Now it's correct. This is probability notation. I can see now that that 4th component is satisfied and the answer is around 16%. That component is now satisfied by the way that I wrote this answer. And again, you could have written 0.159, 0.16, 16%, 15.8%. You can describe it as a percentage or a decimal. Any of those would be fine. So if there was an opportunity on this question to get an E, I think this was it. So if you correctly included all 5 of those components, that's an E. If you got 3 or 4 of those components of the 5 listed above, you have a P. If you have 2 or fewer, that would be an I. So you should make your best guess at whether you have an E, P, or an I for this part of the question. Write it down, and we'll go on to section number 2. So section number 2 has 6 components. So the first 4 components are all from part B. So we should look at that pretty carefully. Here's part B. So part B is a classic. Describe this distribution. And in this context, it's aspen tree diameters from this sample. So you should describe the shape. You should describe the center. You should describe the spread. And you should mention if there are unusual features, such as outliers, or if there is a gap. If there are no outliers, you should also mention that. So in terms of the rubric, first component in B, the gap around 7.5 inches is identified and the lack of outliers is mentioned. Both of those things have to be mentioned. Now notice here, I wrote the distribution of aspen tree diameters has a shape that is skewed right with a gap between about 7 inches and 8 inches. And I never mentioned outliers anywhere. So this will not get credit for component number 1. You did not write about the shape components that were most important here. So it's not a wrong statement, I suppose, to say that this distribution is skewed to the right. I would agree that most of the data are here on the left, and then we have kind of a trailing off to the right. I don't disagree with that, but that's not the most important characteristic of this shape. The most important characteristic is that there is a gap here from about 7 inches to 8 inches. Also, there are no outliers. Both of those have to be mentioned in order to get credit for shape. So the second component, you could either write about the median or you could write about the mean. You should refer to a specific measure of center. You should also use an approximation term like the median is about this, the mean is around this, the median is approximately this. So the median value to get credit for center needs to be somewhere from 5 to 6. If you wanted to describe the mean, that's fine. It needs to be somewhere from 6 to 7. So let's take a look. My statement here says the median is 6 inches. That's not a true statement. It's good that you're mentioning the median, that's a measure of center. But what you need to say is the median is around 6 inches. You could say the median is approximately 6 inches. I doubt that you took the time to enter all 30 observations into your calculator and calculate the real median. That's actually not something that you should even try on the AP exam. You shouldn't take the time to do that. So instead, that's why you approximate it. You say the median is around or about this value. So this would not get credit for the center. So component number 3 is about the spread. So here you could describe the range or you could describe the IQR. You shouldn't use the standard deviation because of the shape of this distribution. The standard deviation is meant to describe distributions that are symmetric or at least approximately symmetric. Moreover, a standard deviation approximation would just be a stab in the dark here. You really can't guess that from the data set. You'd actually have to enter the data somehow into your calculator, and it's just not worth the time to do something like that on a question like this. So if you want to talk about the range, that's fine. You should use an approximation term. You could say the range is about, around, approximately 6.5. So somewhere from 6 to 7 would be fine. If instead you wanted to talk about the IQR, which I think is a little bit more difficult, and I would stick with the range typically, but you could say the IQR is about or around or approximately 3.5 inches. You could say somewhere from 3 to 4 would be fine. So this answer would get credit then for the spread, but it is not because of this statement. It says the data are spread out from about 3.75 inches to 10.25 inches. Well, in that statement, I haven't mentioned a specific measure yet of spread. I did here though. So the range is around, so there's an approximation term, 6.5 inches, the 10.25 minus the 3.75. So the way this answer is written, it only gets credit for the third component. It does not get credit for components 1 and 2. It does though get credit for the fourth component. So notice, B, the answer in B is in context, so you have to be talking about diameters. And units, inches, are used somewhere in your answer to B, C, or D. It has to be somewhere. So let's take a look. Just by copying the words, the distribution of aspen tree diameters, we have context in there. And if we scan through the answers here for B, C, and D, I can see that inches was used in at least one location in B. So we are good to go then with the fourth component. So right now my answer has met the third and the fourth component. The fifth component then moves on to part C. The point estimate should be 6.3. The margin of error should be 0.7. But you can't just list them. You have to show the work for them, even though it is incredibly simple. So right now, my answer to part C does not get credit. I will not get credit for this component of the rubric. I listed the point estimate and I labeled it. That 6.3 is the correct point estimate. This is also the correct margin of error. I labeled it. I even used the word inches there, but I haven't shown any work. So to get the point estimate, this is the lower boundary of the confidence interval, and this is the upper boundary of the confidence interval for this population mean. So the point estimate is the sample mean, and it is exactly in the middle of those two confidence interval boundaries. So you should show the work, and it's not hard to do even if you're typing. You should take the 5.6 plus the 7. You should divide that by 2. That's where the 6.3 comes from. Even when the work is simple on the AP exam, you must show it. That is something that we typically see in rubrics. An answer without work is typically not an answer you're going to get credit for. Same thing with the margin of error. If this is the point estimate, the margin of error is how far above that point estimate or how far below that point estimate you go in order to find these boundaries. So to find the margin of error, I just usually take the upper boundary, which is 7.0. I subtract the point estimate of 6.3, and that will give me the margin of error of 0.7 inches. So you have to show that you're taking the average, or at least state that you're taking the average of the boundaries. You could show the work here. That's probably the simplest thing to do. Or you could say, I'm taking the upper boundary and subtracting the point estimate of 6.3 to get 0.7. That would be fine. So, but understand, correct answers, great. Work is required even when it's simple. So component number 5 was not met because we didn't show the work. So component number 6, in D, you need to answer yes, and you have to write a justification by saying that 8 is not in that confidence interval for the mean diameter. So let's take a look. Here, again, the question, we're using a confidence interval to come to a conclusion. So based on this interval, do we have evidence that the mean diameter for all aspen trees in the park is different from 8 inches? And the answer has to be a yes. So the confidence interval 5.6 to 7, it does not contain 8. So technically, I was done when I wrote this statement here. So I wanted to write it in context, so I continued by saying 8 is not in there, and a confidence interval is supposed to capture the plausible values for the truth, in this case, for the true mean diameter of all of the aspen trees in this park. So I concluded then this is not a plausible value for the mean diameter of all aspen trees in the park. I suppose you could write it this way. This is a two-sided alternative, so we're looking for evidence of a difference. So I suppose you could say there is no evidence that the mean diameter, or rather, because I said that incorrectly, let me say that again. Because 8 is not in the confidence interval, that means that we do have evidence. You could also write this would be fine. You could say because 8 is not in the confidence interval, we do have convincing evidence that the mean diameter for all aspen trees in the park is different than 8. That would be fine. But the bottom line, the reason that you can come to that conclusion, the reason that this statement is a yes, ultimately, you have to be describing that 8 is not in that confidence interval. So the answer that I showed you there is not a bad answer, but it only has the following components met. So component number 3 was met, component number 4 was met, and component number 6 was met. So this gets a P. So in order to get an E, all 6 components have to be included. So, which I will be honest, that's not impossible to do here. There isn't anything here that's necessarily difficult. It's just that there's a lot of detail in all 6 of these components. Of course, that's also why you have a good chunk of time in order to do a question like this. So for a P, 3, 4, or 5 of the components should be included. If you have 2 or fewer of the components, that would be an I. So looking at your response, give yourself as best you can determine an E, a P, or an I, and let's go on. Section 3 has 5 components. So the reason that E, this part, is all alone by itself is because E is important enough by itself. It merits its own EP or I because it is the component of this question that is about sampling and experimental design. So the first part of the question, part A, is pretty much from the normality and standardizing scores, or Z-scores unit for our class. That was chapter 2. This section of the question was from the first chapter about describing shape and center and spread. So this section then by itself, starting at E, that's about sampling and experimental design. That's an incredibly important and a critically important part of AP statistics. So being able to write and communicate about this carefully is important. So your job is to describe a better sampling method. So I'm going to reread the question. I think this is important. Aspen trees tend to be smaller in the highlands of the park because they're subject to strong winds, while the number of aspen trees in the highlands of the park is about the same as the number of aspen trees in the lowlands of the park. The park ranger's concerned that 24 out of the 30 trees came from the highlands. So fine, propose a sampling method that will address this concern. But then you have to describe the benefit of using this sampling method. So in terms of the components you need, number 1, you need to use the term stratified random. You should be using not just a stratified sample, but it needs to be a stratified random sample. That's the method that you should be using. You should not call it blocking. Blocking is a term that we would use in a situation where we are doing an experiment and we want to have some control over a variable we think might confound the response. This is not an experiment. This is an observational study, and I want to sample randomly from 2 different groups. So it would be fine to say this. You could say that I'm using a stratified sampling method, but then somewhere in your description, you need to explain that you are randomly selecting aspen trees from both the lowlands and the highlands. So the word stratified needs to be in there and the word random needs to be in there. And for the second component, you can't just say that you're selecting from both groups. You must describe them in context. You are selecting trees from both the highlands and the lowlands. So let's look at those first 2 components. A better sampling method would be to use a stratified random sample. Great. There's the first component. Using a stratified random sample, they could take an SRS. That means simple random sample. That is an abbreviation that's perfectly acceptable to use in the AP exam, of 15 trees from the highland, and then a separate SRS of 15 trees from the lowlands. So this meets the first two criteria, the first 2 components. We've used stratified, we are using randomness, and in context, we are selecting from both the lowlands and the highlands. Now, something to think about, it says here that the number of aspen trees is about the same from both locations. So when you are randomly selecting, it is advisable that you should use a similar number of trees randomly selected from both groups. So continuing on now, that was component number 3. The method suggests equal or proportional representation from both locations. So here, component number 3 is satisfied because we're taking an SRS of 15 from the highlands and 15 from the lowlands. Why 15? Well, 15 and 15 makes 30, and the original question was about a sample size of 30. It would have been okay to say we're randomly selecting the same number of trees from both the highlands and the lowlands, or a proportional number of trees from the highlands and the lowlands. That would have also satisfied component number 3. So the answer I've shown you right now does satisfy 1, 2, and 3. Now it's on to the part of the question that can be trickier. So components 4 and 5 are about explaining the last part of the question. So bottom line, propose a sampling method to address this concern, but again, we have to describe the benefit of using this sampling method. So how are we addressing this concern here by using a stratified random sample? So the problem is we think the diameters of the trees in the highlands tend to be smaller, and in the lowlands they tend to be larger. So the issue here is variability in diameter. That's what we're trying to account for. The location of the trees, highlands versus lowlands, has an effect on the variation that we see in terms of the aspen tree diameters. So that variability in diameter needs to be mentioned. But then in our description, the advantage of selecting from both the highlands and the lowlands, that why are we doing that? Why are we selecting those two locations in particular? Well, because it's those two locations that we should link to that variability in diameter. Why is there variability in diameter in the first place? Well, it has to do with the winds. So from the highlands, we tend to get smaller diameters. From the lowlands, we tend to get larger diameters. And because of that, that's why we're using a stratified sample, so that we are accounting for the different diameters in trees from both locations in terms of our overall aspen tree population. So notice, all that I wrote here was this way: trees from both locations can be equally represented. At this point, I haven't done anything to describe the benefit of using this sampling method. The benefit of using this sampling method isn't so that both locations are equally represented. That's what the sampling method accomplishes. Why are we doing that? Well, we're doing that because the two different locations have different diameters. So we are accounting for the difference in diameter due to location by using a stratified random sample. That needs to be described. That's what's required in order to get components 4 and 5. So we need to be mentioning the variability or the difference in diameters between those two locations, and it has to be linked to the idea of location. So right now, the way that my answer is written, I have the first 3 components. 3 or 4 components is certainly good enough for a P. You have to have all 5 components here included to get an E. If you have 2 or fewer components, that would be an I. So let me go back and change my answer then. If I wanted this to be an answer that is an E, the following would satisfy that. We could say the benefit of this sampling method would be that it makes sure that trees from the highland and lowlands were equally represented to account for the variability in tree diameters between the highlands and lowlands. So in other words, you have to describe, why am I doing that? Well, there are 2 locations, and those 2 locations explain the difference in diameters, explain the variability in diameters. Well, by equally representing trees from both locations, we are doing a better job of representing the overall population, because we believe that the overall population of aspen trees, we have about the same number in both locations. So bottom line here, at the very end, your overall score is based on your 3 E's, P's, or I's, just like on the previous question. 3 E's is a 4, 2 E's and 1 P in any order, that would be a 3, 2 E's and 1 I, 1 E and 2 P's, or 3 P's, again in any order, that's an excellent score, those are 2's. 1 E, 1 P, and 1 I, that would be a score of a 1. An E and 2 I's, that would also be a score of 1. 2 P's and 1 I, that would also be a score of 1. Again, those can be in any order. Otherwise, it's a 0. So bottom line, give your best take at Is it an E or a P or an I for each of these three sections, 1, 2, and 3? Find your overall score. But again, don't worry so much about the overall score. At this point in the class, as we get ready to take our AP exam very soon, the point of this is to think about and reflect on how specifically do we have to write? What are the kinds of things that need to be included in order to earn credit? So plus there's so much good review here. Think about what we reviewed here. In section number 1, we reviewed how to deal with and communicate calculations involving normality. In the second section, we reviewed not just how to work with confidence intervals, but we also looked at how to describe distributions, shape, center, spread, and unusual features. That's just almost certainly something that will be somewhere on the AP exam. Section number 3 involves sampling methods. Sampling and experimental design is such an important part of this class, and it's important not just to know the vocabulary and to be able to drop a particular term, but you have to be able to justify, why am I using that procedure? Why is it important here? So you have to describe that in the context of the question. So many good things to learn by reviewing. So the bottom line is, I want you to score it, give yourself your 3 letters and determine your score. But the most important thing when you submit your survey after scoring your mock FRQs is to reflect on, tell me something that you learned by doing this second FRQ, something that you've been reminded of or you've picked up on that will help you when you write the real AP exam.